Test, Test. So. Sehr schön. Freut mich wieder total, dass wir so viele Gesichter bei der JUG heute begrüßen zu dürfen. Wir haben heute auch einen spannenden Talk, kleine Meta-Informationen hinweg. Wir haben draußen ein bisschen Merch ausgelegt, gerne mitnehmen, auch die Tassen. Bedient euch an der Stelle. Und wir haben auch für 20:30 Uhr Pizza bestellt. Ich hoffe, die kommen pünktlich. Das werden wir sehen. Wir haben aber heute Hauptattraktion natürlich ist unser Speaker mit dem Talk von Zero to OpenTelemetry. Und ja, ich denke, du willst auch noch ein paar Worte sagen?
Ja, vielen Dank für die Anmoderation. Ich finde es immer super. Ich mache Werbung und gehe zu synyx und synyx macht den Rest hier mit Anmoderation und Essen und Häppchen und Getränken. Also ja, wäre toll, wenn ihr nachher noch alle bleibt und vielen Dank auch an dich, Michele, dass du zu uns gekommen bist, um uns heute mehr über OpenTelemetry zu erzählen.
Thank you for having me. Today's talk is going to be in English. First of all, my German sucks. And second, the jokes are funnier. Raise your hands, please, if you have heard me already talk about OpenTelemetry. Excellent. So I can reuse all my material from before and it's going to be fresh new for you. Amazing. Raise your hands if today, right now, this very moment, you have software running in production. Keep your hands up if you care about that software. It's not a given. And now keep your hands up if you know exactly whether it's working as you expect. Wow, you're such an honest crowd, I love it. How do you know that your software is not working right now? Louder, please. Yeah, this is something very German. People will scream at you if it doesn't. Normally, the golden standard is that this tells you. And in order to know whether our software works as intended, we need to monitor it well. The talk today is about one of the best improvements to the world of cloud computing and operating software that I've seen in my career, OpenTelemetry. It is a standardized way of collecting information about the health status of your application, and this sort of joint common language to talk about metrics, traces, spans has actually opened up a lot of space for innovating where observability and monitoring have sucked forever, and that is the user experience. Nevertheless, by the way, I was not supposed to mirror, so let me do it properly then. I'm terrible at this. Alright, so today I'm not going to talk about my product, or the product also, Rafael is also one of my fellow people at Zero. I'm just going to talk about OpenTelemetry. Feel free to interrupt me with any questions you want, heckling if you feel in the mood. Everything is fair. And at some point you will need to stop me from talking more because I have a lot of things to say. Alright, this being said, who am I? I am Michele, head of product at Zero. I am an engineer specialized in performance monitoring and then observability that figured out I could program more and faster by doing it via Outlook. So I went into product management, but I still product way too much. I program way too much. You find me on social media, but it's not worth it, so leave it be. Now, I have been using long words. Monitoring, you understand, but observability, what is that? Well, we had the little questionnaire before. Observability is knowing what is going on with your system. And you're going to find, depending with who you speak with in the industry, depending what they are trying to sell you, they may have a very specific definition of observability that fits their particular philosophy, or they may be a bit more chill and relaxed. I belong in the second category. I'm chill and relaxed because observability is effectively monitoring with a trench coat. To put it philosophically, observability is a property of your application. You can understand what it is doing. You can interrogate telemetry about it and figure out what's going on. Monitoring is what enables observability, is the act of collecting, hopefully, the correct telemetry. And also process it into alerts and make this thing buzz when stuff is on fire and so on. What you see on screen here is something I did while I was working at Canonical. I started asking people, hey, what's your take about observability? Is it something new? Is it just monitoring? And of course, Twitter being Twitter, they went to the funny answer. But in reality, it's if they try to tell you that observability is completely different than monitoring, is because they have a product to sell you that relies on that. Something also very interesting is that the way people search on Google changes dramatically depending where you are. In the old continent, people search more for monitoring than observability. In the US and Canada, so North America, where marketing is the fiercest in the industry, observability is a very widespread term. And this data is from 2021, so of course I went and looked it up again. And monitoring is very widespread and observability as well, except if you look here in Equatorial Guinea, where apparently they know what's up and it's observability all the way. So I do not have an explanation for that, but it's amazing, and they might be the next Silicon Valley or something. Now that we are on the same board, on the same page about what is observability, let's talk about OpenTelemetry. OpenTelemetry is a lot of things. It is a set of specifications driven by a number of experts across the entire observability and monitoring industry. Like every single major player has two hands and both feet in it. It's not driven by any specific vendor. It is a set of APIs that you can implement if you want. It's a set to collect telemetry. It's a set of implementations of these APIs. These are known as SDKs. Imagine it like the Prometheus client library, but much more powerful, that can do more than just metrics. It is a format. It is an interchange format for telemetry that is known as the OpenTelemetry protocol, OTLP, and it should be probably the only format that you should consider adopting to transmit at least trace data. I'm going to talk more about it later. There is also a bunch of utilities. There are some very cool projects. If we have some time, I'm going to talk about it, about all the kind of things around OpenTelemetry. And it's huge. It's the second largest project in the Cloud Native Computing Foundation. According to some metrics, like I think the amount of contributors and maybe commits, it is the largest, larger than Kubernetes. And it's pretty cool. There is a lot of fun to be had. What it is not, which is equally as important as what it is not proprietary. You are, by adopting OpenTelemetry, you are not locking yourself into a specific vendor. This is very important. It's not driven by a single vendor. Some of the things, when you go and talk with experts about the nitty-gritty details of how OpenTelemetry is designed, you will realize that some of the choices are the minimum common denominator that is going to work across most vendors. Luckily, it's still good. OpenTelemetry is not a query language. OpenTelemetry is a way of collecting data, not about querying data. There is no OpenTelemetry query language. Although, I should mention, in the tag observability of the Cloud Native Computing Foundation, there is work ongoing to design the one true query language for OpenTelemetry. It's a bit early days, but it's ongoing. OpenTelemetry is not a backend. There is no official OpenTelemetry database where to store the data, and this is where competition is the fiercest among vendors. OpenTelemetry is not feature complete. New stuff is coming online all the time. For example, if we get lucky this year, we're going to bring stable continuous profiling, an entirely new signal. And OpenTelemetry is not boring. Sometimes it's exciting for all the wrong reasons, like trying to figure out some particular bug or how to support a particular library, but in general, it's a lot of fun. Now, I was speaking about multiple types of telemetry. Raise your hands, please, if you monitor your applications using logs. We all do. If you didn't raise your hand, it's because you're asleep. Raise your hand if you monitor with metrics. Raise your hand if you monitor with traces. And now raise your hands if you're monitoring web applications from within the browser. You kind of. Mobile? Anybody from mobile? No? So you see, there is actually an entire spectrum of types of telemetry, which we will later see how they map in terms of applications. The signal, so the type of telemetry, the word to use is signal, that more represents OpenTelemetry, the poster child of OpenTelemetry, if you will, is distributed tracing. It is a way to collect across interactions in a distributed system a sort of breadcrumb of interactions that are taking place. And I'll give you some examples later on. Then there are, of course, metrics. We all love metrics. We mostly use metrics with Prometheus today. Raise your hand if you're using InfluxDB or Telegraph. Represent. So there are, but mostly as an ecosystem, we moved towards Prometheus at large. Logs and events. So lines of text with a timestamp. Yeah. If somebody is trying to chat you up about the difference between logs and events, nod and then try to get out of the conversation as soon as possible. The two things are effectively the same. Profiling. Profiling is very exciting. The kind of things that we used to do in the privacy of our laptops to figure out why something is slow, by collecting at regular intervals where is the CPU being spent, what is allocating so much memory, what is stuck waiting for I/O wait. In the year of the Lord 2025, we're now doing it all the time in production. This is enabled via technologies like eBPF, the extended Berkeley packet filter, and there is some very exciting things going on there. But also we have been doing it all along with Flight Recorder in Java, if just anybody bothered, because the setup was a bit difficult, and SSHing into containers to attach the profiler was not a great experience. Last but not least, real user monitoring. This is where you track the user from within the browser. This is actually another spectrum of things. You can go like the kind of Sentry way, where you do error monitoring, collecting errors and stack traces from the console of the browser. Or it could be, for example, collecting web vitals about how quick your page is, all the way into stalker mode, so session recording and replay. The kind of things that you use Amplitude, Postdog, and other tools like that for. For session replay, by the way, if you're interested, there is effectively a standard that's called RRWeb. It's not part of OpenTelemetry, but literally every single tool you've ever seen doing session recording uses that. So it's actually something to look at. There is actually technically also mobile, real user monitoring on mobile. It is a different beast. The people that do mobile applications have a different set of needs. For example, if your web browser, like if your application in the web browser crashes, then it's Monday. If your application crashes on somebody's phone, that application gets deleted and never opened again. So for example, when you look at things like Firebase, Crashlytics, and products like that, they are much more aggressive in collecting some types of information like crashes, and they need to live with very different limitations in terms of how to give you data. For example, on a web browser, you can assume the web browser can stream data out. In mobile, not so much. People may be using the app, it might crash, and they may not have any signal. So as you see, there is a very big jungle of different things for different types of applications. And in the center of it, in the world of OpenTelemetry, there is the OpenTelemetry collector. Raise your hands if you have deployed an agent from some observability vendor. So, for example, when you use a tool like Instana, Dynatrace, Datadog, New Relic, AppDynamics, Elastic, so pretty much everybody in the past had proprietary agents. A process, hopefully hardened, that you would install on your virtual machines, on your bare metal hosts, inside your containers to collect information and transmit it to the backend. Maybe SaaS or something on premise. That role in the world of OpenTelemetry is largely fulfilled by the collector. For the few people that raise their hands when talking about influx, the collector is effectively Telegraph on steroids. It's effectively a process, a modular process. You can build your own versions with a bajillion plugins to receive information in different formats, transform them inside, filtering, adding metadata, removing metadata, sampling, all that you can imagine, it can do it, and then send it somewhere else to tools like InfluxDB, ClickHouse, Elasticsearch, -0. This is the only shameless plug I have in the talk, by the way. Any questions so far? Yes?
Does collector run inside your application pod or outside?
The answer is yes. The collector runs wherever. The question was, does your application run inside your application or outside? Technically, it's its own process, but in the world of containers, you would think your pod as part of the application. There, you could have it as a sidecar. The SDKs, these things, are running definitely inside your application. This thing could run beside your application with different levels of distance between the processes you're monitoring and the rest. Anything else before we continue? Good. Now, we have spoken about a lot of different types of telemetry, and a natural question is, why do I care? Which ones do I need? Put it in a more friendly fashion. This is my opinion on the matter. This is the classic layers that you will find in cloud applications. And here on the right hand side, the kind of telemetry that I think you should be using to monitor the different layers. Starting from silicon, bare metal, logs and metrics. For example, the people of Oxide, which is some very expensive, very cool looking hardware that you can put in your data centers, you will monitor those big chunks of silicon with logs and metrics. The same thing is a hypervisor. Has anybody had the pleasure of monitoring Hyper-V? No. If you had the questionable pleasure, you will know that you will get some metrics, you'll get some logs, and you better like it. The operating system, for example, your Ubuntu's, Fedoras, Windows, whatever, it's mostly logs. You get some metrics. For example, imagine collecting what the top command says at regular intervals to see what's hogging all your CPU, or in other words, which process has a Bitcoin miner inside. True story, by the way. I've been there, done that. And then profiling. For example, there are several ways of profiling on an operating system. strace, ptrace on Linux, eBPF, with the idea of figuring out what is consuming the CPU in your processes and try to remove the bottlenecks that way. And as you notice, the higher we go in the stack, the richer the jungle of telemetry becomes. And this is because the higher we go in the stack, the less hardened the technology is. If you find a bug in the Linux kernel, amazing. It happens to us roughly once every 5 years if you try. A bug that you find in the code that we together write for our web application, it's 1 minute. So you need more observability, you need more telemetry. The less the software is hardened, the less reliable is the software, the less you can trust it to do what it should. And that is inversely proportional to how many people use it, and that is how fast the bugs are found. Also, I should mention, if you're not looking for bugs, you may not find them, and observability is a great way of finding those bugs. Now, after we leave the world of operating system, we're going to the magic world of cloud and containers, where stuff got incredibly complicated very fast in the last 20 years. Container orchestrations, I'm thinking Kubernetes, but if you'd asked me 5 years ago, I would have also said Nomad. I would also have said Cloud Foundry. Now less. Or serverless. Think of your Lambdas, think of your AWS ECS on Fargate, think about Google Cloud Functions, think about Azure App Engine, think about Azure Functions. Those are all systems, those are all computing platforms where your span of control, the kind of things for which you can get information, is very limited. I'll give you an example. If you deploy code on Lambda, the only thing that you really control is your own code. If you are deploying your Node.js application on an Ubuntu VM inside your vSphere, you can do whatever the admin pleases. Maybe not you, but the admin. But go and try to get telemetry about the kernel from AWS and see what the answer is. It's usually some version of laughter. And then we go one level higher. We stop talking about just the runtimes or applications run, and we talk about the applications themselves. This is where our containerized applications live, our processes. And then we go one level higher and we start talking about IoT and mobile and user devices. By the way, when people talk about IoT, they tend to think like cool stuff like robots and routers. The actually most difficult thing that I've ever had to monitor together with customers was a photo booth. Photo booth. You would go in, take a silly picture with hats, and then the customer would end up and wait in front of it. And the image was sent to a cloud server to be optimized and then sent back. And if that didn't work, then the poor sod taking the picture with the funny hat would wait there like 10, 20, 30 minutes and then probably vandalize the place and go away. So as you see, the stakes can be very high in IoT. Now, so far, great, lot of theory, kind of stuff that you care about. As you see, the more we go up, the more we get more things. This is distributed tracing. I'll give examples. Real user monitoring, because if you have a web shop, your checkout button is literally putting bread on the table. And then you also do things like synthetic monitoring. So, for example, if you have used Pingdom, Catchpoint, Checkly, and a bunch of other vendors, something that will go and regularly try your APIs, your web UI, for example, using Playwright to make sure that it works. Very good. Any questions so far? It's a lot of information, don't be shy. No? All right. Good. How do you get yourself some OpenTelemetry in general? Because OpenTelemetry supports a lot of different languages, and then we will look at Java and the JVM in particular. So, if the answer is, how do I monitor my application? The answer usually is yes, because there are so many ways of doing that, and there are different trade-offs, but I'll try to give you a solid starting point. Now, When we talk about monitoring applications, we usually will want to add some auto instrumentations. Auto instrumentations are a capability in OpenTelemetry that has been available in different vendors for a long while to not only have the library that knows how to produce telemetry installed in your application, but also add at runtime to the logic of your application callbacks to collect the data. Actually, raise your hands if I talk about aspect-oriented programming. Do you know what it is? Thank you. You have carbon dated yourself. I'm sorry for that. I'm also from that generation. I have no shame. The idea is that you would wrap around, for example, specific method invocations and start recording telemetry when the function was invoked and when the function returned. Keep the timing, when it started, when it ended, and collect information about how it went. That is instrumentation in most cases. You have something for me?
I would like to change the...
All right. I'm sorry. So how are you monitoring these things? The answer is no.
Yeah, but the green light doesn't count because it's not working. The battery is dying. So the should be orange. Yes.
So it's not great monitoring. 1, 2. So this is operations in practice. Have you seen the monitoring was not great? Okay, let me try to actually get this. It's like very complicated and embarrassing. Good. So you start with automatic instrumentations. In OpenTelemetry, there are automatic instrumentations for most languages covering usually 90% of the libraries and frameworks you're likely to use. And it's usually a great starting point because they get you really far into the journey of collecting telemetry with almost no work done. And I'll give you an example of how to do that in a couple of ways with Java. Then there are languages without the civilized notion of a runtime, like Go, Rust, C++, where you cannot really modify them at runtime with instrumentations, but there is eBPF. Raise your hands if you know what eBPF is. Keep your hands up if you tried it. So eBPF stands for Extended Berkeley Packet Filter. And if you think it sounds like networking, you're perfectly correct. It was meant to do high-speed networking and in some cases drop packets very, very fast. For example, the first versions of Cloudflare, if I recall correctly, were actually using eBPF to drop packets in case of DDoS really fast. And it has evolved slowly into effectively its own programming language inside the kernel. There is a virtual machine, there is bytecode that is verified. You can do a lot of wonderful things. Most security products nowadays are using eBPF if they can. When I was the product manager at Instana, I actually used eBPF to detect how processes would crash by hooking into the kernel when the process memory was deallocated and see what the signal was that killed the process. Did it quit on its own, or was it killed because of auto memory by a sick kill? That's very interesting stuff. Nowadays, there are a few projects out there, and the most notorious are Odigos and Grafana Bela, to automatically add OpenTelemetry instrumentation to languages like Go. So effectively, the idea is that whenever your program invokes a particular function, the kernel invokes a callback that is running eBPF to collect, for example, details about your HTTP requests. And it's quite cool, provided that you have access to the kernel, which is not a given on the cloud, because try to use eBPF on Lambda and you see what happens. Usually the answer is nothing because it doesn't work. Now, We have spoken about applications. In this talk, I'm not going to talk about, for example, mobile or web. That will keep it for another time, another meetup. What do you do if you're not monitoring applications, or maybe not only applications, you're monitoring infrastructure, like Kubernetes itself, like virtual machines, the operating system. You're doing mostly Prometheus and logs, and it's good. Those technologies are relatively well understood. You do not need a lot of very complex telemetry to figure out what's going on. There are many techniques about how to use the telemetry well, but you need less complex information. And if you do this on Kubernetes, raise your hands if you use Kubernetes. Well, decently cloud native, very nice. You could try using the OpenTelemetry operator instead of the Prometheus operator to collect data from the same endpoints and send it somewhere else. For example, if you used, let's say, the looks good to me stack of Grafana, you could use the OpenTelemetry operator, scrape your Prometheus endpoints, and send the data to Grafana. It's possible. I usually do not suggest people to install Prometheus and run it in the same cluster as the applications you monitor, because when the cluster has a problem, then you have absolutely no information whatsoever. It's usually a good idea to have some separation between the infrastructure that contains the monitoring data and where the data is coming from. Logs, we have been using logging agents like Logstash, Beats, FluentD, FluentBit, and a bajillion others for forever, and there are many different formats, and what you're doing today is fine. You can use it with most tools out there. But what do you do about sending your telemetry? There is open source you can start with to use with OpenTelemetry. For example, for metrics, you could use Prometheus, or you could use Thanos or Cortex, which are effectively Prometheus reimagined to scale better and harder. For traces, you could use Jaeger. Has anybody here used Jaeger? Nice. So it's a system to show distributed traces. For logs, for example, OpenSearch. The people of Victoria Metrics have made Victoria Logs. Looks interesting. You could try that. So there is a bunch of options. Besides actual open source, driven by a community, not by single vendors, then there is OpenCore. For example, I mentioned Victoria Logs for this. The Grafana Labs looks good to me stack. You can run it on your own without asking them anything. That works. Good luck getting PRs in if they don't like it. That's the difference between open source and OpenCore. And there is a bajillion other vendors that have OpenCore. For example, Signos has it. OpenObserve has OpenCore. So there is a lot of stuff that you can use for free. That's the message. And then if you find that maybe you don't want to run the monitoring software on your own, and you'd rather have somebody else be responsible for that, there is a bajillion vendors with both on-premise support and SaaS support, software as a service, like Dynatrace, Datadog, Splunk, Honeycomb, Elastic, Dash Zero. There is a bajillion. And the nice thing with OpenTelemetry is that since now the format is the same, you can try multiple without changing the way you collect data and pick which one you like best. And you should really do that, because many times in my experience, what is keeping you with the current vendor is just a pain in the backside to have to change the telemetry collection. Imagine going and ripping away 100 agents running in 100 different places and replacing them with something else entirely. With OpenTelemetry, that is probably the last agent you're going to install. And I find that really cool. In case you wonder, to get your feet wet with monitoring and OpenTelemetry, start with open source. It's always a great idea. Don't talk to sales unless you have to. Good. Any questions so far? No. Then let's get some Java. And the answer is, again, it depends, but less. So there are a few options, but not nearly as many as you have across a variety of languages and possible setups. In the Java system, there was something truly exciting in around the year 2018. Can anybody guess? Now we can run Java on the JVM and on Graal, the Graal VM. So OpenTelemetry in Java to work on any Java virtual machine above 8, and if you're using 7 or less, I feel for you. I really do. I don't want to be mean because I know people that use Java 6. So there is a lot of different libraries and versions of all types of HTTP clients and database drivers and everything else supported. Can somebody make a guess how many different Java HTTP clients are out there used by somebody somewhere? Yes, who offers more?
50.
Very good. That was my last count, and that was 5 years ago. Then I gave up. So there is an incredible variety of clients, and if OpenTelemetry does not support your client, you may not have the information you need. There is a list, you can go here, of all the things supported. It is a very long list, so chances are there is something for you in it. Some frameworks have actually built-in support for OpenTelemetry, and this is quite cool. When you nowadays use Spring Boot with a couple of lines of XML, you can add micrometer tracing and automatically collect distributed tracing data from Spring Boot and metrics as well. Before, you could do it with Spring Sleuth, for example. There are like Micronaut and Quarkus also, but I'm going to talk about it a bit later. Unfortunately, and this is something where I'm not super happy about it, Spring Boot people decided to reinvent the way to configure monitoring. I'm not on board with that, but it works for them. So just so you know, if you want to use the built-in instrumentation from Spring Boot, you need to go and learn the very specific Spring Boot ways of configuring things. What is probably going to get you confused as hell is the fact that the Spring Boot configurations will automatically throw away 9 traces out of 10. And imagine my joy when I was trying to set it up and I didn't see data coming up in there 0. And then only until out of a bout of rage I started refreshing the page of the application a lot. Then I saw data and I understood what it did to me. Also, we're going to maybe talk about it later. The way that you annotate your telemetry is very important. If one application calls, for example, the HTTP method, http.method, and the other calls it HTTP request method, then you're going to have real problems searching across all your telemetry. This is something that in OpenTelemetry is regulated by the semantic conventions, which I love with a fiery passion, and the Spring Boot decided no, nobody cares, we're going to keep doing what we did with Zipkin, which it's not true that they don't care, but they have not upgraded them yet, and it upsets me. And then there is the world of GraalVM for Java processes that start up really fast. That is, most of the time you're using GraalVM by effectively compiling ahead of time your code, so it looks much more like Go than it does Java. And in that way, you cannot really add the instrumentation at runtime. You need to bake it into your application at compile time. And Graal is used in most frameworks out there. Quarkus has probably the best support for OpenTelemetry I've seen. It's good stuff. The Spring Native has also support for that. Unfortunately, they use the same instrumentation as Spring Boot, so not great. There are ways to use the OpenTelemetry instrumentation at compile time with Spring Native if you want. I've tried a few times, but I never used it in production, so your mileage may vary. Micronaut has also support for OpenTelemetry, which is cool. But also the semantic convention support is not amazing. And this leads to a break in the blah blah blah, and let's look at some telemetry, shall we? I want to give you a taste of what it feels to add instrumentations to an application. And I already have it running because I do not trust my luck with demos. But what I did, I built a very simple Spring Boot application. It's like the kind of things that Josh Long used to tweet. Yeah? And the only thing it does is having a get API that just very politely tells you hello. And this thing works. Let me find the right browser window. I can go here and do hello. Cool. Amazing. Best application ever. No bugs. Have you seen anything inside here about OpenTelemetry? None. This is just plain, maybe not boring, but plain Java Spring. So what are we doing there? Let's take the other way around. Let's go and look from the Kubernetes aspect. I should say, trigger warning, you're going to see some YAML. So if you're allergic to that, close your eyes. What you see here is a lot of stuff. Most of this stuff is really about configuring the way the application will collect telemetry. But as you see here, there is a bunch of auto here, and this says, hey, yeah, do use the Java agent that you have inside the container, and this is where you send the data, and this is the authentication that you send with the data. By the way, this thing here, YAML anchors, they are the best way to confuse the living fuck out of somebody else. That makes the YAML file not self-contained. Is great for documentation because when somebody copies and pastes, nothing's going to work. So they cannot copy and paste bullshit configuration because nothing will ever work. And then there you actually replace it with the actual values. And then you see here other things like metadata. This is OpenTelemetry semantic convention stuff. But I mean, so far we have seen naked code and configuration. So where's the hot stuff? Where is OpenTelemetry? Where is the instrumentation? This is where I should point out there is a second trigger warning. We're going to look at a Docker file. But it's not really a Docker file. I'm going to cheat and do it with Maven. Now, Maven, which is a build tool from a more civilized era, if you ask me. Yes, I love Maven. If you are a hipster Gradle person, I'm sorry, you need to write your build configurations every time they release something. Here it's doing, I do not want to get a dig at you, but I have to say it. Here is doing something rather boring. So it says, hey, I want the Spring Boot starter for web. This puts all the dependencies to have effectively Spring MVC or Webflux if you feel funky. The actuator, this is very important. This in Spring is effectively the API that implements for you the health checks and a bunch of monitoring capabilities like metrics with Prometheus. So far no OpenTelemetry yet. This thing here is where it gets funny. So Spring Boot has done something quite cool. Since a while back, they effectively taught Maven how to build container images. And that is done using Cloud Native build packs. Cloud Native build packs is effectively an addition to a build process that adds to your container image the JVM and a bunch of configurations to make it work. Java security properties, dependencies like OpenTelemetry, the OpenTelemetry Java agent. Things like how to set up the memory collection in Java. Raise your hands if you know the memory layout of the JVM. Good, none of you is a liar. configuring the memory layout of the heap of the young generation, the old generation, the native memory, and a bunch of different things. It's actually very complicated in the JVM, especially in an environment like containers, where very often you have very precise, very strict limits about how much memory you can allocate for the process. And the build packs have something inside called the Java Memory Calculator, which is a very nice way of have very good configurations without any work. So if you are on the market of making your Docker files better, I know only one way, and it is do not Docker file and use a build pack instead. If, however, you insist on doing the Docker route, then I need to can I unplug this for a second to find the right file? Does it explode if I do? Very nice. Give me a second, I'll give you another example. I need to remember which presentation to use. Almost there. Have patience. Your Docker file is going to be served now. Almost now. So let's look at a different way of get your application monitored with OpenTelemetry. And this is through a normal Docker file. And this is one of the simplest Docker files you can imagine. So we say, yes, we want a JDK, please and thank you. And this is where the application assumes it's going to run. And this is the jar file of my application. And then we add to the Docker file the OpenTelemetry Java agent, which is itself a jar file. So the OpenTelemetry Java agent is written in Java using bytecode instrumentation. And then with this environment variable we do magic. The Java underscore tool underscore options is a way to tell the JVM that there are additional startup parameters. So instead of me having to go and in a very uncivilized fashion adding here minus Java agent blah 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 blah, I can put that environment variable and it counts the same as if I added from let's say here all the way to here inside my entry point. And you will ask, Michele, why are you making it so complicated? First of all, excellent question. Secondly, it's because I wanted to show you a very cool mechanism to add stuff to your container without changing your container image. You could actually, and there are things like the OpenTelemetry operator that use that mechanism plus additional containers added at runtime to your pod to deliver OpenTelemetry instrumentation and activate it without you rebuilding your container image. This is called no-touch instrumentation. Sometimes it will be called auto instrumentation. It's a misnomer and it's amazing. And if you want, I can show you later how it feels. So we have seen different ways of effectively doing the same thing, and now let's go and have a look at what is happening in my application. So I already started the process, and this is just the log files that I see in Kubernetes. It is a simple Spring Boot application. It's doing nothing useful. It's just waiting, and now we'll go and make its life a little more interesting. And then I can see data in -0. Now this is a pretty lonely application. It's talking to nobody. It's just one single web application, one single web page. And you will see when you look into the telemetry tab that it's actually doing a lot of things, sending a lot of data, sending a lot of tracing data, and it's sending a lot of metrics. Let's go and have a look at the anatomy of tracing data with OpenTelemetry. You see here two types of operations, so the kind of things that the application is doing. The first one is me pressing F5 in the browser, and I go and fetch index, and the other one is the actuator. Can you tell me why the actuator has been invoked so much? Which health check specifically? The liveness check of Kubernetes. Well done, sir. Effectively, in Kubernetes, you can configure in your pod very easily that the platform itself should check at regular interval if the application inside your container is still alive. It doesn't mean it's working, but at least it's not dead. Now, when you go and look at tracing data, you will find, I'm now going to go pro mode and just look at the format of OpenTelemetry. This is OTLP JSON, and it is a way of serializing your telemetry. There is other encoding, mostly protobuf, and people are working on Arrow, Apache Arrow, which is meant for columnar databases and ingest data very, very quickly. And you will see here a few things. So there is a start time. This is where my request was received. There is an end time. This is where the Spring Web Server says, I'm done answering to you. And when you subtract this thing from this thing, then you have a duration. How long it took from the point of view of the web server to answer. So this thing. Notice that although here it says 1 millisecond, OpenTelemetry actually measures in nanoseconds. It's meant for stuff that goes very, very, very fast. And then you have a lot of metadata. For example, the client address. So what is the IP address on the other side of the TCP connection? You see a bunch of stuff in there still that you don't care about. You see the HTTP request method, for example, GET. If I sent a post or if I sent a head request, that would have a different value. You see a bunch of stuff about networks, the protocol, the version, the address port, stuff that is specific JVM, thread ID and thread name. This, for example, has values that are very Spring Boothy. This one is telling us that it's NIO, so it's Tomcat with non-blocking AO. You also see in the name which HTTP endpoint was invoked, and something else that is important for tracing, and I'm going to switch to a more complex application to show it. What happened before? In this case, nothing. Now let me switch to a more interesting application. I'm going to switch now to the OpenTelemetry demo application. It's an official application of the OpenTelemetry demo process, and it is much more complicated. We have a lot of components running inside. Some is Java, some is .NET, and there is a bit of something in every language. And for example, when we go and look at our product catalog service, we see that it's also doing a bunch of distributed tracing. And for example, we can do something like, let me find something not boring. No, that is the wrong type of excitement. Let's say this. This here is a distributed trace. The kind of information I was showing you from my boring Spring Boot application, here it's being collected through multiple services in a call, in a tree of calls. So when you look at the map, let me open it in a different window. These kind of pathways are how components are invoking each other. But not every request that starts, for example, here or here does the entire thing. This is just kind of the sum of all the traces. When you go and look at a specific trace, you see that it actually behaves like a tree. So this, the beginning of the trace, is known as the root span. It is the only span in a trace that does not have a parent. There is no span that says, I am here because of that. And then it goes, for example, in this case, there is a span created for the receival of a request, and then there is a span created because my front-end service is calling something else downstream. In this case, it's going to the checkout service. The checkout service does a bunch of things, including something internal, and it goes and talks then with the cart service, but then it also talks with the product catalog service and the currency service, and so on and so forth. So as you see, this is effectively a ledger about the important things that happen in the process of serving one request. And if you have to deal with complex distributed systems, which, let's face it, you probably have to because microservices were way too cool, this can save your life. Usually, errors happen deep inside and propagate upwards. Latency is built inside and mostly propagates from the outside, unless, for example, you're doing something like messaging, where your client will reply and say, I'll take care of that, and then the data is processed asynchronously. In OpenTelemetry, traces are associated with logs. So for example, I can go and see that this log happened during this span. There is also another type of logs called span events, which is, shall we say, vestigial data structure in OpenTelemetry. When OpenTelemetry was started, it was the mix of two projects: OpenTracing, which was just about tracing, and OpenCensus from Google, which was metrics and tracing. Notice that neither of these two projects wanted to do anything to do with logging. But they realized that they need to describe events. And as I told you before, events and logs are the same thing. So OpenTelemetry first invented logs as span events, and then decided, okay, let's bite the bullet, let's actually do logging. And now there is a bit of duplication. Yes?
One question about the span and the parent, you get the parent span, how to correlate them in order to get the tree.
Excellent. So, when you look here, the trace is painted, the trace is painted as a tree going forward from parent to child. In reality, it's backwards. When we look and at, for example, the trace here, and I go on the source, you will see that the parent ID is empty. This is the root span. You will find inside a span no information whatsoever about its children. And I will explain it to you in a second. And I need a second piece of evidence for that, a child, and this only knows what the parent is. So it's effectively a tree built backwards. Why is that? Because when you, for example, invoke a different service, you issue an HTTP request, you have no idea whatsoever if the other side is traced as well. But the other side receives the so-called trace context. And to give you an example of trace context, I need to Google just a little bit. In OpenTelemetry, the trace context is done with this format. And let me see if I find it. There we go. This is the trace parent header. Remember I was telling you how instrumentation... bigger, sorry, thank you. Remember how I was telling you that instrumentation wraps around pieces of your code and collects telemetry? It's not the only thing it does. In many cases, it adds metadata to outgoing requests. This thing here is meant to be added to your outgoing HTTP requests as an HTTP header, or as metadata in your gRPC request, or as metadata to your JMS messages, or most protocols support. Yes, sir?
What if you have kind of an inverse relationship? If you have a front end making requests to the back end, then some random service periodically pulls the back end, processes the data, and returns the result, and then it's returned back to the front end. Then the request is the wrong direction to pass on the parent.
So the trace context is propagated from caller to callee.
Yes, but in this case you will need to split it somehow.
Not really, because you see, your front end is not going to have a separate connection to the service in the back end. For example, the way that I understood your question is, let's imagine this is my front end. Let's say this is running the browser, and this calls this, and this calls this. The trace context goes in this direction, but there is no direct communication starting from here and ending up here.
There is one from, like, the front end calls the back end.
Yes.
And a third service calls the back end.
Yes. They are different traces.
Yes, and then gives the result back, and then the back end knows, okay, I got the result from the third party service, and then it forwards it back to the front end. So in the middle there's like a random other service making requests to the back end, processing data periodically.
It's likely going to be a different trace. We should look at the code, because there are many ways to realize this constellation, but in that case you would have two routes, and traces do not merge. In OpenTelemetry there is a concept to relate traces. It's called span links, but it's a very advanced topic. So, and you use it mostly in asynchronous messaging when you consume multiple messages at once. Each of those messages could be generated in a different trace, carrying a different trace context, and then your consumer needs to start a new trace and link it to all the previous ones. And this is the only way in OpenTelemetry where you effectively traces kind of merge. Because normal tracing, it's from child to parent. A parent can have any number of children, but a child can have only one parent. So it's a directed acyclic graph.
I guess the alternative is to hack the third-party app to take the random response from the parent and inject it into its context and override its own ID. And then you have a merged trace where one part is just left hanging around alone.
I want to see which scenario you're working with. Then I can help you monitoring it properly. In that case, traces doesn't really work like that. It's complicated a bit. If you had something like a diamond structure, then traces are going to merge, then they're different traces, right? Could even be sometimes that you have a trace that reference to different spans in the same upstream, but it's almost never the case. Good. I'm actually curious about what you have gone through to tell me your experience. I'm curious. Something else that you will see here, and I find it actually quite interesting. This is a query to a database. There is no tracing data coming from the database itself. Can you guess why? Remember what I said about the more well understood the technology is, the fewer types of telemetry you need? It's almost never the case that databases generate trace data. You usually trace their clients. Some Java-based databases like Cassandra or Elasticsearch can be instrumented to collect trace data, but it's usually pretty useless. It doesn't really give you much, because what really matters is how the client perceived how long it took. If the database says, cool, it took me 9 milliseconds, and the client is there waiting for 1 minute because there was, for example, a PG bouncer in front of it, so process the queue's connection to avoid overloading the database, nobody cares how fast was the database. The client was slow. It's going to be slow for your end user. Yes? Any other questions before we move on from tracing and look at the magic world of metrics? Yes, sir.
How would you do it with events?
How would I do with?
Events, like messages?
Yes. So in OpenTelemetry there are 5 types of spans. And those are the so-called span kinds. Let me see which ones I have to play with here. Only server, so let me drop a few filters. These are the 5 kinds. Let me make it bigger. Too big? Good. For messaging, the pair is consumer and producer. The consumer is the one that gets a message from the queue. The producer is who puts the message in the queue. A similar pair is server and client. This is, for example, my Spring Boot application, and this would be the browser, or maybe something else invoking an HTTP or gRPC API. Last but not least, internal spans are something that you should use when you want to document something that is happening within your application. The classic example is using object relational mappers. Raise your hand if you have childhood trauma from JPA. I feel for you. My heart goes out to you. So the object relational mappers are effectively a way to do SQL without dirtying your hands with SQL, and people are convinced that it helps them, when in reality it does terrible things. And you should at least know how the actual database queries map to the invocation that you give to the API. For example, when you use Spring Data with the repository pattern, for the love of Christ, collect spans around your invocations on the repository, so that if it fools you once more and give you all data because of caching, then at least you see that no database query was issued. And then you know why the data looks old. Yes?
Coming back to the messages part, what overhead do you see?
Speaking to the cube, the hypercube.
Thank you. In your experience, what kind of overhead you see in using OpenTelemetry in, let's say, in an application that is like messaging, and we need, let's say, we need the messages in the milliseconds latency.
OpenTelemetry has, in general, very little overhead. Of course, you can do terrible things like caching data inside your Java application instead of flushing it to your monitoring backend, and then, for example, you incur an additional garbage collection. But very often, you don't really manage to measure the overhead in terms of latency. It's mostly a matter of additional memory being consumed because of the creation, for example, of spans in memory and collection of metric data points. Most of the memory allocations happen off your critical path. So the APIs are usually either doing very little allocations or doing them off thread. So you don't really add latency to your application. You do have some overhead in terms of garbage collection, although if you configure properly your OpenTelemetry or leave the defaults, almost always the telemetry you collect is going to reside in the young generation. And garbage collecting that is crazy cheap. You don't really care. If you do funky things like submit data every 5 minutes, then if that thing gets into 10-year memory, then you're screwed. So don't do that. Flash your telemetry often, and of course you will see an increase in network connection being used to flash the data upstream. Although OpenTelemetry data tends to be very nicely compressible, so you can send. There is a bunch of data application going on. So you tend not to see nearly as much overhead as you would think. I hope that answers the question.
Yeah.
In terms of the messaging itself, what does OpenTelemetry add to my outgoing messages? Well, the answer we have already seen. It's this. It just adds a little tiny bit of metadata. By the way, I failed to explain what this is. I always get it wrong. I think this is the version of the spec. This is the trace identifier. This is the span identifier, the kind of thing that you would have as parent or span ID, and these are trace flags. Trace flags, there is only one that you actually care about. It's called sampling. The idea is that in tracing you can instruct your downstream systems to ignore this trace. You're saying, hey buddy, I'm not collecting it, drop it, nobody cares. This is something, for example, the progenitor system of a modern distributed traces, Dapper, invented at Google, had sampling turned on by default, I think, to tracing only one request out of 10,000. Because if you're Google, you can drop 9,999 requests and still be very statistically significant in your chance of catching errors. If your application is doing that, cool. But in reality, don't do sampling until at least you're sure you're not missing stuff. Okay? Good. So now you know everything there is to know about tracing, which is nice. Tracing saves lives in distributed systems. You do not give a rat's ass when you're doing a monolith. And if you can do a monolith, you should. Remember, do the simplest thing that works. Now, we've spoken about distributed traces. By the way, distributed tracing as a monitoring practice well, it exists like since forever, which means in our field roughly 25 years. It actually became popular because of distributed systems and microservices. Because when we used to do architectures that were sensible instead of copying Google, nobody needed more than 10 different systems talking to each other. Interestingly enough, companies that are really, really good at what they do, and they do it at large scale, they still don't use distributed tracing. Google themselves or Netflix, for example, they don't trace every single request. Their monitoring infrastructure would cost more to operate than the actual business one, right? So they use distributed tracing as an on-demand signal. There is a lot of cool tools out there used by the big boys that allow them to select under which conditions is a particular trace being collected, and that usually has the name as of sampler. The simplest sampler that you can imagine is the one that always says yes, so trace me everything. The second simplest is the one that just throws a very large dice, and then if the number is just right, it will trace that request, and otherwise no. Anything else about tracing? Raise your hand really high because they're blinding me here, so I don't see anything. All right. Yes, sir. No? I hallucinate. Oh, cool. No? Maybe I hallucinated a question.
I'm not seeing anyone.
Excellent. Then I completely made it up. You see, I'm very modern. I'm using AI to ask questions. It's great. Let's talk about metrics. Metrics, you will, in a broader category, you have three types of metrics. The ones about your infrastructure, CPU usage, memory usage, amount of open files, amount of available space. Metrics about your application, for example, amount of time spent in garbage collections, or a histogram of how long it takes to answer requests. And the third one is the most important one, is business metrics. How much money has my service done? In monitoring, people tend to only collect technical metrics, so how much computing resources and so on. If you want to be a pro, you also collect your business metrics and relate them with the infrastructure one. That, if you want to make your PM happy, that's what you do. Those two things belong together. Now, let me go back to my simple thing, and you will see here a bunch of metrics that should really not surprise you, like JVM CPU count, recent utilization, CPU time, GC duration, amount of memory committed, and so depending on the different part of different memory area of the JVM, and so on and so forth. Literally all of these are collected out of the box by the OpenTelemetry Java agent. You can also instruct the OpenTelemetry Java agent to use JMX to collect metrics, which is very cool if you've done monitoring for a while, so you already have your application work with JMX and you can keep using that stuff. you can also go and encode in OpenTelemetry, create your own metric instruments to collect your custom data points. And there are, let's say, 3 types of metrics that you actually care about. I'm going to use the OpenTelemetry terminology. The Prometheus one is only marginally different. The first type is the sum. The sum in Prometheus, we would call it probably a counter. In OpenTelemetry, sums are not necessarily always increasing. They can reset. So, for example, if your process crashes, your metric can restart from 0. This is the way that you use to count things. How many requests have I served since the startup of my application? How many bytes have I streamed out? How many errors have I thrown in the face of the user? The second type is the gauge. Gauges go up and go down. So, for example, you use gauges to collect telemetry about rates. How many requests have I answered in the last minute? How many active connections do I have right now? Last but not least, the one that is probably the coolest, let me get an actually cool one, is the histogram. A histogram is actually a complex metric that counts how many data points you have in a specific bucket. And I'm going to make it very concrete to you with an, let me see if I find an example in the OpenTelemetry semantic conventions. There we go. So imagine that what you want to do is to keep track of how fast your requests are. You could use tracing, and then if you're serving 10,000 requests a minute, you have 10,000 spans a minute, and that's money. Or you could create a metric that is very cheap, and then you count how many requests were faster than 5 milliseconds, faster than 10 milliseconds, and blah 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 blah. So effectively you are bucketing, in this case, the response time of your application in counters, and then you send it back to your observability backend, and then you can calculate percentiles. Raise your hand if you know what a percentile is. Raise your hand, keep your hand up if you know what the difference with a quantile is. So a percentile is, the two things are, unless you're talking with a nerd for telemetry like me, they're effectively the same thing. But when I take, for example, a histogram, the percentile is, in this case, the 50% percentile is the value under which there are 50% of my data points. The percentiles are really common when you start talking about SLOs. Your product person will come and say, I'm going to be very upset if for 99 requests out of 100 it takes more than 1 second. So they will tell you 99 requests out of 100 must be at the most 1 second, must take at most 1 second or less. This is what the percentile means. It's the value under which a certain percentage of data points lives. The quantile is the same thing, but instead of being between 0 and 100, it's between 0 and 1, where 1 means 100%. People usually talk about percentiles. When collecting metrics, quantiles are very common because it's more mathematical, it's cooler. Yeah? Something else that you can do with histograms is to calculate averages. A word of caution: do not use averages to make alerting about the speed of your application. Who has done? Everyone has done it. Who is the last doing that? Raise your hand if you did it yesterday. Come on, don't lie to me. So why am I saying that average is a terrible idea? Because averages lie. What is the average of 0, 2, and 6? 0, 2, and 4. Let's keep it simple. The answer is 2. What is the average of 0, 0, and 4? No, let's say 0, 0, and 6. Sorry, the math in my head is hard. It's also 2. If a request takes effectively 0 twice and 1 6 seconds, is much worse than if it takes a much more distributed thing, but the average is the same. So if you want to set targets about performance of your applications, use percentiles or quantiles, do not use averages. Okay? Good. One last thing I wanted to show you is logging, which is the most boring of the bunch. In OpenTelemetry, logs are thrown into multiple buckets. Technically, error and fatal are two different categories because people like to bike shed way too much. In reality, you don't care. It's always bad. Error or fatal doesn't matter. Warn, info, you care about those. Trace and debug is another academic distinction that I refuse to abide. So they're all the same thing. And unknown can be the case, for example, when you use the OpenTelemetry collector to collect your files, you may not parse the severity of the log correctly, and then the collector says, I don't know, it's unknown. Logs in OpenTelemetry are very, very similar to spans. So you have a bunch of attributes. You have a pointer to the span ID and the trace to know during which span the log was collected, but it's not really a parent-child relation like in tracing. For example, a log does not have to have a span ID. A log is perfectly happy without knowing what is its parent. And then logs tend to have a much more complex body. In this case, it's just a lousy string, but you can actually put entire structured JSON logs in here, and it works. So if you can do structured logging, do it. It's a great idea. In OpenTelemetry, you can structure it by putting attributes in OpenTelemetry, as well as nesting complex data structures in the body. And probably you're all going to do this, because this the OpenTelemetry way requires using complex instrumentation to do that, or being very good at the OpenTelemetry SDK. Good. Yes, sir?
How do you do logging? Is it the normal log frameworks? Or
Yes. Thank you. I forgot to say this. Remember how I said that you should do the simplest thing that works. The simplest thing that works is the one you already have. So OpenTelemetry has a way to collect metrics in the OpenTelemetry format and logs in the OpenTelemetry format. If you already are collecting metrics, for example, with Prometheus or logs with FluentBit, keep doing what you're doing. Very often, for example, remember I was talking about the OpenTelemetry collector. So when we look at this picture here, these things can generate logs. This is, for example, when you use a log bridge. Since I'm talking to Java people, a log4j appender that gets a log and transforms it into OTLP format and then sends it off process. That's a classic log bridge. This thing can collect logs. For example, if you are reading logs from a file to send it somewhere else, this does it with the file receiver. If you are inside here, you probably know which trace is going on. If you are in here, you do not, unless the trace context was stored on the log. Now, in general, what I would advise is do logging based on files, because it's almost impossible to have OTLP based logging for the entirety of your application. Remember, I was doing a Spring Boot demo, You know the Spring Boot logo, the super cool thing. You cannot collect it via OTLP. OTLP is bootstrapped after in the process, and there are entire category of bugs that you will not be able to capture with an OTLP log. In Kubernetes, I'm even more prescriptive. Do not break kubectl. So keep doing logging using the standard output and standard error of your container, and then get the logs using, for example, a daemon set that goes and reads the logs from the var log pods folder of the node. That is the better way, because you really should avoid the risk of not having all the logs you expect. This being said, there are situations where doing OTLP logs is a cool idea. Also for new applications, can be fun. But in general, if you have something that works, stick with that. Yes?
When you use, for example, SLF4j, how would you get the markers, not the markers, the span IDs in? Is it like with MVC markers, something like that?
So what happens in Java, I don't have a slide for this. As your request traverses JVM, there is effectively a thread local variable that keeps the counter of where you are in the trace. The instrumentation that, for example, is for Tomcat. Let's say you have an instrumentation on a filter. The filter adds the trace ID to the request context or the trace, depending on the implementation. And then on the other side, when, for example, you have the database reads the trace context, uses to create the database span, and then it's done with it. And then on the way out, the threads clean after themselves. This is also the case, for example, if you use an executor service, then there are instrumentations that when you start a job, they get the trace identifier on the thread that is starting the job, copying it on the state of the thread that runs the job runs in the trace context, then the trace context is deleted from the thread that you're going to reuse, and your trace continues from the other side. So it's mostly trace context. It works very differently, for example, in Kotlin coroutines or in the virtual threads of Java 17. So Loom threads or virtual threads, there you have instrumentation that works a bit more like Go coroutines, where effectively those things are anyhow closures. So you have the trace context restored before and removed after, not to taint the rest of the requests. If you screw up the cleanup of the trace context, you have the worst category of bugs in distributed tracing, and that is called trace context breakage. If you break the trace context, it either looks like your trace makes no sense, or your trace is broken, and you have a root span where you shouldn't have. And that's because something failed at moving the trace context correctly, or you're missing an instrumentation, or something like that. Good. Are the pizzas here?
Yes, pizza's here. Any closing questions? Or are we at the end?
I mean, I can talk until the pizzas go cold, but nobody wants that.
Are you hungry?
I have sugar. I can go on until... So, in summary, observability is super fun, and if you have not spent enough trace monitoring your system, is a great adventure that I strongly encourage you to bring on. You can challenge yourself endlessly to monitor your application better and better. And your applications will always have a new fun way of crashing, so it's never boring. To start with Java applications, if you're running on a JVM, the Java OpenTelemetry Java agent is amazing. Try it out. If you're running on GraalVM, use the built-in instrumentations in your framework. And having telemetry is cool. Knowing what telemetry means is cooler. And I am actually going to leave you with one last thing before we get the pizzas. Give me a second to find the right slide for this. And it's going to be a quiz. So prepare mentally to be very, very smart. if I am smart enough to find it, of course. The last time I used it here. Let's go. All right, ready? Let's go. Wrong screen. What do you think this means?
Graph.
Louder, please.
Graph.
Cool. Can you be more specific, sir?
A red graph.
That is correct and yet disappointing at the same time.
Technically
Anybody
correct.
with taking more risks?
Matterhorn. Latency.
Matterhorn, nice. Yes?
Latency.
Latency?
Dead
Cool.
application.
Huh?
Dead application.
Bad application? Dead application. Why dead?
Because
In the end.
lots of metrics and then suddenly nothing anymore.
Cool, that's a nice guess. It tapers down. Anybody taking a guess on the color? It's red. When was the last time that red was good, right? Remember, semantic colors are important. Well, remember, I never told you, but now I'm telling you. Semantic colors are important. Yellow is not great and red is bad. If you have a tool that doesn't use these conventions, it's a shit tool. And you can tell them I said so. Now, in reality, it's this. The message that you must bring away from this exercise is that telemetry without context is just data. If you do not know what it means, it's useless in the best case and misleading in the worst. So remember, telemetry that you do not understand, throw it away. It's pointless. Good, and with this cheery little anecdote, I think we can go and have pizzas.